Hey Sam, it's a great question about constructing a confidence interval for a population mean given a sample from that population. So some quick things to go through. When describing populations, your mean is mu, your standard deviation is sigma, and your sample size is capital N. And when describing a sample taken from that population, the sample size is lowercase n, standard deviation s, and mean is x bar. We're given all the information we need here to calculate this confidence interval. That's our sample size, our sample mean, our population standard deviation, and the level of confidence that we want here. Now this is at heart a central limit theorem question. And essentially what that says is that for any distribution, the sample mean is normally distributed around your true population mean. This is real powerful because this tells us that we can estimate this true population mean given a sample standard or a sample mean in any sample that we have. Now, we know that our 99% is the confidence interval that we want, and that gives us an alpha of 1% because alpha is 1 minus our confidence interval. And that tells us that the excluded data that won't be in our confidence interval is 1% of the data, right? And that 1% gets split into both tails, right? This is the cutoff value for x bar that we have here. And anything beyond these values is cut off. So I hope you have some familiarity with z-scores because it's really powerful. It standardizes any distribution around 0. And it's a tool that you can use to kind of back calculate what these values of x bar will be given a confidence level, right? Now, remember I said the alpha here is essentially getting split into both tails of the distribution, 0.5% each. So we don't want to find the z-score associated directly with alpha. We want to find the z-score associated with our alpha divided by 2, which will give us these values here, or technically these values here, that we can then use to transform and find what our margin of error will be to subtract and add to our sample mean. So I'm going to go ahead and do this in Excel. It's a lot easier. And if you're going to be doing a lot of statistics, you should familiarize yourself with some of these Excel tools. So I've set us up here for success. We've got our sample size, our sample mean, population standard deviation, the confidence interval, and the alpha associated with that confidence interval. Now I'm going to take the absolute value of this z-score associated with alpha divided by 2, just because it's a little easier to work with. So that's absolute value. Now to get a z-score from any alpha that you have, you're going to use norm.s.inverse. The probability here that it's talking about is your alpha. And remember, we're doing alpha divided by 2 because alpha gets split into both of those tails of our distribution. Now, our sample standard deviation, I'm going to walk back a little bit. I'm going to talk about that. This is a distribution of averages around the population mean. And in order to construct your margin of error here, you're going to multiply your z-score associated with your alpha by this term here. And this is kind of, you can think of it as your standard deviation of your sample distribution. And all that is your population standard deviation divided by the square root of the size of your sample. And intuitively, if you think about it, this shows us here that this margin of error will get smaller and smaller and smaller with a larger and larger sample size, bringing you a more close approximation of your true mean here. So this is the sample standard deviation we're going to be using in our approximation of margin of error. So we're going to go back to Excel. Remember, that's equal to our population standard deviation divided by the square root of our sample size gives us 2.8. And our margin of error is just our z-score multiplied by that, 7.21. Now, in constructing our confidence interval, we want to add and subtract that value from our sample mean, which is what I'm doing now. And boom, there you have it. This tells us that our confidence interval is 166 to 180. I hope this helps. If it doesn't, drop me a message and I'll try to make things more clear. Thank you.